In the last class, we discussed digital logic design flow and why digital logic design we discussed. And today, we will discuss how to represent the truth table and with the help of truth table, how to write the Boolean equation. We know that there are two types of Boolean equation. One is this normal form, another one is the standard form. And also, we will see how to write the minterm and maxterm, and we will see how to convert the normal form pos into a standard SOP or pos. So now, how to construct the truth table? We know that if I want to construct any truth table, I should know what is the problem definition. So now I will make one problem definition. See, if this is the combinational circuit, this is my combinational circuit, and it had 4 input variable x0, x1, x2 and the x3, and 2 output, one is y0 and another one is y1. Here I will give the problem specification. This is the first one. I want my y0 should be 1 if and only if the input is equal to 5 or less than 5. The second constraint is I want y1 output should be 1 if input is equal to 9 or greater than 9. So now with the help of this constraint, now I will construct the truth table. This is what my problem definition. For this problem definition, now I will construct the truth table. As I said, I need a 4-bit truth table here. See, 4 input variables are there. One is x3, x2, x1 and x0. This is actually a LSB site. LSB is nothing but of lower significant bit, and this is the MSB site. This is called most significant bit site. So in this case, there are 2 output. One is y0, another one is y1. See, now I will force the vector. The vector forcing time, see here I will start with 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0. Again it will continue. Next is, now I will start with 1, 0, 0, 0, 1, then 1, 0, 1, 0, then it will keep on continuing till 1, 1, 1, 1. See, this one I am representing, this indicates the decimal 0, this indicate decimal 1, this indicate decimal 2, this indicate decimal 3, this indicate decimal 4, this indicate decimal 5, this indicate decimal 6, keep on. Then 1001, this indicates 9, this indicates 10 in decimal, but in case of hexadecimal, I am going to be representing this as hey. Then it will keep on continuing. The value of this hexadecimal is decimal is 15, and hexadecimal equivalent is f. And for the hexadecimal, this is 0 to 9 is same as decimal, but whereas in case of hexadecimal, after 9, 10 we are representing with A, and 50 and the 11 B, 12 C, like that. 15 we are representing with F. From 10 to 15 we are representing with alphabet A to F in case of hexadecimal. Now some student having doubt like how we are going to be representing this. This is 0, 0 is equal to 0, how 0, 0, 1 is equal to 1. So here I have taken 8421 code representation, 8421 code representation, because here we are going to be representing the binary value, because 2 to the power of 0 position, this is the 2 to the power of 1 position, this is the 2 to the power of 2 position, and this is the 2 to the power of 3 position. So whatever I am representing this position, that 2 to the power of 2 equal to 1, 0, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is 8. So here I have only 4 bits, so that's why I am using 8421. If it is the 5 bits, then it will be 2 to the power of 4, then I will get here 16. But according to my scope, 4 bit is more than enough. So related to that 4-bit, I am going to be representing now. So 4-bit is more than enough. For example, if I want to represent 0, I will make each and every bit is 0, 0. Then this weightage is 0. Now if I want to represent 7, so then I need 4 for 7 plus 2 is the 6, and one more I need 1. So 4 plus 2 plus 1 is 7, and 8th one is, I don't want this position, I will make it 0, then its equivalent is 7. Similarly, if I want 10, then what I will do, I will make this position as 1 and this position as 1 and the remaining 2 are 0. So this is indicate the decimal 10 or the hexadecimal equivalent is A. This is how I have written this truth table. In this case, as I said, what is my constraint? So according to my constraint, so if the y0 is 1, only if input binary value is 5 or less than 5. So this is less than 5, I will make y0 output is 1. Similarly, this is less than 5, and this is also less than 5. This is also less than 5, less than 5, less than 5, but this is not less than 5, and this is more than 5, then I will represent these things as 0, 0. So from here onwards till end, it is 0. Now, if I talk about y1, so what y1 says that if input is equal to 9 or greater than 9, I need to represent by 1. In rest of the case, I need to put 0. So from 0 to till 9, we need to represent with zeros. Once it reaches 9, so according to the constraint, y1 equal to 1 if the input is equal to 9 or greater than 9. So then from 9 to till 15, output is 1. This is how we are going to be representing the truth table. This is the 4-bit truth table. So now we should know, so with the help of this truth table, how to write the Boolean equation, Boolean function or the switching function. Now we will see if I want to write any Boolean function, or we can say switching function. See, we can possible to construct any Boolean equation or a Boolean function or a switching function with the help of Boolean variables and its operation. I mean to say is, by connecting the Boolean variable with the Boolean operations, we can able to construct any Boolean function or the Boolean expressions. So if I take one example, f of a, b, c, which is equal to a plus b into b plus a bar. So this indicates actually a function, this function having 3 alphabets. So this indicates this is an 3-bit truth table. The equation we got from the 3-bit truth table, and here this is called as an variable or literal. So sometimes they are telling that is literal or it's also called as a variable. Now there are 2 types of Boolean function as we discussed in the introduction. So types of Boolean functions. One is normal form and another one is the standard form. Again, in the normal form there are 2 types. One is SOP and another one is the pause. Similarly here also SOP and the pause. SOP is nothing but of sum of product and pause stands for product of sum. Now we will discuss the standard form is also called as a canonical form. Now we will discuss one by one. First we will discuss what is normal form, how we are going to be representing the normal form. In this normal form, first we will discuss SOP. If I want to write any SOP equation, for example, f of ABC, which is equal to a bar b plus ab c bar plus ac. See, in this case, this is represented as, see here, this AB, this is the product term. It had three product terms. These are called product terms. This product term get added with the plus operator. So that's why it's called sum of the product. See, this product we are going to be summing. This is the product. And this is called, these terms are called conjunction. Conjunction. So in this case, if I want to say this complete equation is this in disjunctive form. The terms are in conjunction, but whole equation is in disjunction form. Next, similarly, we will see how exactly we are representing SOP, sum of the product of sum. Next is the pos. This is product of sum. Similarly, if I write f of ABC, which is equal to the same term, I will represent in the form of pos, a plus b bar, a bar plus b bar plus c, then a bar plus c bar. This is called an pos form. In this pos form, these terms are get connected with the product. See, this is the multiplication. This is sum, so product of the sum. See, we are going to be producting the sum terms. So that's why it's called POS. We are going to be producting this sum term. So these terms are called sum terms, or also we called disjunction. But overall equation looks like conjunctive form. This is what the normal form, one which we are representing the Boolean equation in case of SOP and in case of POS. Now we need to discuss what is standard form, or we can say canonical form. In this case, see, first one we will discuss standard SOP. Okay, this is also called an minterm, and this one we are always representing with the symbol summation of m. This is the symbol, one which we are using to represent the SOP. Now we need to discuss what is standard form, what is canonical form. Since before we are representing any SOP equation, first we should know what is standard form or the canonical form. In case of standard form, each and every variable of the function must be there in each and every term of the Boolean equation. Once again I will repeat. Each and every variable of the function must be there in each and every term of the Boolean equation. See, in this normal form, we are not finding each and every variable is present in each and every term. See, here only AB is there, C is not there. Similarly, here ABC is there, not a problem. But here AC is there, B is not there. So this is not a standard form. This is only a normal form. If I want to represent any standard form, what I said, we should know the definition. The definition is each and every variable of the function must be there in each and every term of the Boolean equation. So how to represent that? So now I will represent that. Say for example, f of a b c, which is equal to a bar b c plus a b c bar plus a b c. This is the standard SOP. I mean to say is each and every variable of the function must present on each and every term of the Boolean equation. Okay, so this is the standard SOP. Now we will discuss what is the standard pause. The second one we will discuss standard pause. This is also called max term. This is represented by m. This is the symbol one which we are representing. So then how exactly the standard form equation, standard pause representation f of a b c, which is equal to a bar a plus b bar plus c bar into a bar plus b bar plus c into a bar plus b bar plus c bar. This is the equation for standard pause. Again in this, each and every variable of the function is present in each and every term of the Boolean equation. This is called standard pause. Now we need to see how to convert the normal SOP or POS into a standard SOP or POS. Now we will discuss that. Now we will see how to convert the normal SOP into a standard SOP. Converting normal SOP into standard SOP. How to do this we will discuss now. So normal SOP into a standard SOP. So in this case I will take one example, f of ABC, which is equal to AB plus BC plus AC I will take. So this is the one standard form, normal form equation. Why it is a normal form? Because each and every variable of the function is not present in each and every term of the equation. So now we need to convert this normal form into a standard form. So first step what we need to do, now we will discuss step by step. First we will see the step 1. Step 1, we need to find out the missing literal or the variable from each and every term. So first we need to find out missing variable or literal from each and every term of the Boolean equation. So for that, see if I write the equation, see in this equation if I say AB plus BC plus AC, so what is the missing term in this case? So in this case it's very easy to find out the missing term. So in this, for which one is the missing term? C is the missing term. In this case A is the missing term. In this case B is the missing term. Now in the step 2, what we need to do, step 2, we need to product the missing variable plus its complement to the product term. So how to do that? Now we need to do A, B, which is the missing term C, then we need to take C plus C bar. Next, BC is the product term. For this product term, we need to adding or producting the missing variable and its complement. Similarly, AC, so we need to do missing term and its complement. So next in step 3. Step 3, what we need to do? We need to expand and reorder the equation terms. So how to do this? We need to expand this. So expand means it will get ABC plus ABC bar plus B ABC plus A bar BC plus ABC plus AB bar C. So now we expand and we reorder this also. And this step 4, in step 4, we need to omit the repeated terms. So which are all the repeated terms in this case? So in this case, the repeated terms, see in this case, ABC comes here and ABC comes here also and ABC comes here also. So these two terms we can neglect, and finally we are getting ABC plus ABC bar plus A bar BC plus AB bar C. Totally we are getting 4 terms for A comma B comma C function. So this is my final standard SOP equation one which I have got. In this case, in final equation, we can possible to find out each and every variable of the function is present in each and every term of the Boolean equation. Clear? So now we will discuss how to convert standard SOP, standard pause in normal pause into an standard pause. Now we will discuss how to convert the normal pause into an standard pause. We will see how to converting normal pause into a standard pause. In this case, I will write the function f of a comma b comma c, which is equal to a into a plus b bar plus c. See, this is the normal pause form. This normal pause form we need to convert into a standard pause form. So first we know that what is step 1? Step 1, we need to find out the missing term. So in this case, which are all the missing term? In this case, missing term is B and C. These two are the missing term. In this case, there is no missing term at all. So first case, we find out the missing term. Second, in the step 2, what we need to do? Step 2, we need to do addition of missing term and its complement. How to do that? For example, if I write A into B plus B bar, we need to do, see in this case, we need to do the missing term addition. How to do the addition? In this case, if I need to do addition of the missing term and its complement plus missing term into and its complement. And similarly, this is one more, the existing one which the term is this. So here what we need to do, we need to add the missing term and its complement. See, this is the missing term, the missing variable and its complement. Here this is the missing variable and its complement. This one we are adding with the existing one. So in this case, how I am going to be solving this? See, what we need to do, here I am treating this as complete A and this two I am completely treating as BC. See, we know that according to Boolean algebra, this is the equation you all know, A plus BC, which is equal to A plus B into A plus C. So like that we need to divide. This is the formula or the Boolean algebra we need to apply for this case. So how I will write this? This one I will write A plus B plus B into B bar. Next plus only I will take only C term. This is A plus B. This complete indicates A and this complete indicates B. Next, what I will do next case? Again I will take A plus B into B bar plus C bar. Now it indicates, this complete indicates A and this indicates C. So this is like this, A plus B I did here and this is A plus C I did here. So now the remaining term is A plus B bar plus C. Once again I will apply same strategy or the same Boolean algebra, again furthermore reduction. So what I will do, I will treat this whole as these two consider as A and this two I will consider BC. Similarly here also this two I will consider as A and this two I will consider as BC. Again same Boolean algebra I will apply here also. Then how exactly it looks? A plus C plus B, correct? So this time these two are the A and this is the B. Now again A plus C plus B bar. Now this is looking like, so I will consider this two as an A and this is as an C. Similarly for this I will apply A plus B plus A plus C bar plus B, then A plus C bar plus B bar, and this is one I will return as it is. This one A plus B bar plus C. So now after applying this, so now it's comes in the normal form. So we need to go to the step 4. In the step 4 what we need to do, we need to eliminate the repetitive term. So in this repetitive term ACB is there, here ACB bar, AC bar by AC bar plus B, here A plus C bar B bar plus A plus B bar C. So which is the repetitive term in this case? So according to this, see A plus B once is there, A plus C B bar is there, see here A plus B bar C is there. It repeated twice. So what we need to do, we need to eliminate this one. Okay, repeated term. So finally what we are getting, so this is A plus B plus C. This is the one. Next is A plus B bar plus C. This is one I am retaining, and because this one I have eliminated. So then A plus C bar plus B. Then the last one is A plus B bar plus C bar. So f of ABC, which is equal to A plus B plus C into A plus B bar plus C into A plus C bar plus B into A plus B bar plus C bar. This is the standard Poisson equation. Standard Poisson equation, why? Because which contain each and every variable of the function is present in each and every term of the Boolean equation. So this is the standard Poisson equation. So now we will discuss how to represent the min term and max term with the help of 3-bit truth table. Now we will discuss how to represent the min term and max term with the help of truth table. So now I will take a 3-bit truth table. So here I will use A, B, C, the term, and here I will represent the min term. Here I will represent the max term. The min term is the one we are representing like this, yeah, and the max term one which we are representing with a big gamma. So now we will see that how to represent the min term and the max term. Here I will give the binary weightage 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now we will see how to represent this binary weightage into a minterm and maxterm form. As we know that minterm is representing with this SOP and this is representing with pause, standard SOP and standard pause. Now how to represent 0? So this 0 I am representing with A bar, B bar, C bar. This is the product term I can represent with M naught. Similarly, how to represent this 0, 0, 1? 0, 0, 1, 0 represented with bar, complement of the variable, again 0 complement of the variable. This is the one normal form, no complement, and this is the M1. Similarly, this is A bar, B, C bar, M2. This is A bar, B, C, M3. Similarly, this one I am representing with A, B bar, C bar, M4. This is A, B bar, C, M5. A, B, C bar, M6. This is A, B, C representing with M7. And if I want to represent same thing in a maxterm form, this is the maxterm. In this case, this is just complement of minterm. So where and all product is there and all we need to make the plus symbol. Where and all complement is there, so we need to write without complement. That is A plus B plus C. This is represent with M0. Similarly, this one I will represent in case of pause term or the max term A plus B plus C bar, which is M1. Then this is A plus B bar plus C, M2. And this is A plus B bar plus C bar, M3. This is A bar plus B plus C, M4. This is A bar plus B plus C bar, M5. This is A bar plus B bar plus C, M6. This is A bar plus B bar plus C bar, which is M7. This is how we are going to be representing minterm and maxterm with the help of any truth table. Now, how to write the Boolean equation or the Boolean function or the Boolean expression with the help of the truth table. So, for example, I'm very much interested. I want in my function, in my end Boolean function, I want this term should be there in my final equation of SOP. Then how to represent? See, I can represent that f of ABC, which is equal to summation of m. So this is the 1, this is the 1 I want to be in my equation, in my final equation, and this is the 3 I want to be in my final equation, and this is the 5 I want to be in my final equation, and the 7. So this is how we are going to be representing. But in sometimes some of the question paper and all, how they are going to be representing ABC, they will give the equation like instead of the number, they will give the in the form of terms, that is A bar B bar C plus A bar B C plus A B bar C plus last one ABC. So both the representation are same. So sometimes you may get like this, M1 plus M3 plus M5 plus M7. So this is up to you how you are going to be representing. You can able to represent in all the three ways. Similarly, if I want to represent anything in case of the pause form, see for example the pause form, if I take f of ABC which is equal to pi m, so 1, 3, 5, 6, same number I am representing in the pause form. So again, if I want to represent A, B, C, this will represent like, we know that A plus B plus C, correct? A plus B plus C bar for the 1, see, A plus B plus C bar. Similarly, the next one is A plus B bar plus C. Next one is A bar plus B plus C bar. Similarly, last one is A bar plus B bar plus C bar. So like this also we can represent. At the end, or we can represent M1 product, M3 product, M5 product, M7. So this is left to you how you are going to be representing minterm or the maxterm. Now we will see if we have one truth table. So for the truth table, you need to write for this truth table, you need to find out the SOP term and you need to construct an SOP equation. For example, I will take the 3 variable truth table 0, 0, 0, and this is the output 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is the truth table. In this truth table, this is 0, this is 0, this one I want, this one I want, this is 0, this is 1, this is 0, and this is 1. This is the truth table. From this truth table, I need to construct an SOP equation. This is my input, this 3 is my input, and this is my output. So from this truth table, if I want to construct a SOP equation, which and all I need to consider. So you should remember one thing, which and all the output is 1, only that corresponding term should be there in the final SOP equation. Here, this is the 1 and it should be there in the equation. Here I am getting 1, this should be there in the equation. And this output is 1, this should be there in the final equation. And here is the 1, it should be there in the final equation. So from this, I can write an equation f of ABC, which is equal to, I can write like, this is the 2 representation, M0 plus M3 plus M5 plus M7. Or I can write other way around, I can write this as A bar B C bar plus A bar B C plus A B bar C plus ABC. So, or I can represent, this is summation of M, which are all the terms. So this is 0, not 0, this is not M0, this is actually M2, M3, and this is the 2 should be there, 3, 5 and the 7. Similarly, if I want to write any SOP equation, POS equation, this is the SOP equation, this is the SOP equation. Now, similarly, if I want to write any POS equation with the help of same truth table, I want to write a POS equation. How to write the POS equation? If I want to write any POS equation, there we need to see only the zeros. Whichever the output is 0, that corresponding term should be there in my final equation. So wherever the 0 is there, so that I will consider for my final equation. So now if I want to write the final equation for the same, so that point of time, f of ABC, which is equal to M0 into M1 into M4 into M6. So now I can represent like this also. This is A plus B plus C dot 1 means that should be the A plus B plus C bar into A bar plus B plus C. Then finally this is into A bar plus B bar plus C. And if I write other way, pi m, I can place this as 0, 1, 4 and 6. See, this is how we are going to be representing. This is actually a POS equation with the help of the truth table. So now we learned how to write the Boolean equation with the help of truth table in the SOP form and the POS form. If I want to write a SOP equation, the interest is only whichever the output is 1. If I want to write a POS equation, interest is whichever the output is 0. Is this clear?